In this video, we are going to find out how to create this particular effect by using geometry nodes. Let's start by selecting everything, then delete. Split this area, then change it to be Geometry Node Editor. Add an icosphere in the 3D viewport. This icosphere is going to be the base mesh, and it is the only one going to be needed in this entire project. When it is selected, create a new modifier with a new geometry node group. I am going to rename this one to the Sphere of Rings. Add in Dual Mesh node, then connect it here. You toggle muting of selected nodes by pressing M. The Dual Mesh node creates points at the center of each face, then connects those new points to create new faces. If I disable muting, you can see that the new face is following the annotations I have drawn on the geometry. Add in Split Edges. Split Edges has made each face in this geometry to be an individual element. In order to see what Split Edges is doing, add in a Scale Elements node, then connect it here. If you adjust the scale value, you can see individual faces scaling. In this case, the Scale Elements node is providing this effect because of this Split Edges node. If you mute the Split Edges node, you can see that the whole geometry has scaled down. And if you adjust scale here, the whole thing scales up and down. Also in the Scale Elements node, you can choose between scaling faces or edges. You can see that these faces have sharp corners, they need to be smooth and rounded. To do that, you add in a Subdivision Surface node, after the Scale Elements. Let's increase the subdivision level to 2. The next step is to create some rings around these rounded faces. Before creating those rings, add in a Join Geometry node and connect it here. Add in a Mesh to Curve node, bring it down here. Connect Scale Elements to Mesh to Curve. Add in a Curve to Mesh node, then connect it with Mesh to Curve. Then connect Curve to Mesh node to Join Geometry. As soon as it is connected, you can see that there are new edges displaying around the rounded faces. To give those edges some thickness, we are going to need a profile curve. Add in Curve Circle node, then reduce resolution to 8. Connect curve to profile curve. Let's reduce the radius of the curve circle. Something like 0.035 should be fine. You can see that these rings have sharp corners, they need to be smooth and rounded. Add in Set Spline Type and connect it after Mesh to Curve. You can see that is connected just before the curve is turned back into a mesh. Here set the spline type to NURBS. NURBS stands for Non-Uniform Rational B-Splines. NURBS curves are defined in terms of a set of control points. On this NURBS curve, if I keep on extruding this point, you can see that it maintains its rounded profile. And that rounded profile is what is responsible for making the sharp edges in these rings go away. Let's continue. The next step is going to be making other thin rings around the thick rings. Select Curve to Mesh and Curve Circle, then Shift D to duplicate. Connect Set Spline Type to the duplicated Curve to Mesh. Connect this Curve to Mesh to Join Geometry. In order to see the new rings, we need to add a Scale Elements node. Set the scale to be 1.7. Then reduce radius of this curve circle to a smaller value like 0.0015. On these thick rings, we are going to add some details on them by attaching tiny spheres on their surfaces. Duplicate this Join Geometry and connect it here, and adjust this way. Add in Instance on Points node and connect it here. You can see that the thick rings have disappeared. To display them, connect this Curve to Mesh node to Join Geometry node. An instance object is needed on this Instance on Points node. Add in an icosphere and connect it to Instance. Reduce the radius to a smaller value like 0.01. Also increase subdivisions to 2. The next step is to create a sphere that is going to be inside. In order to create that sphere, the original geometry can still be used. If you select the group input node and you press O, it connects itself to the group output. Since the original mesh is going to work, you can add it in the node tree through a join geometry node. Therefore, connect the group input node to join geometry. The sphere is big, it has to be scaled down. Add in a transform geometry node, then connect it here. Here we are going to adjust scale in all axes. Since the scale is applied to all axes, you can add in a value node, then connect it to scale. On the value node, set it to be 0.9. As you can see, the inner sphere is poking through the geometry above it. Add in a subdivision surface node and connect it here, then set level to 2. Add in a set shade smooth node, in order to shade the surface of the inner sphere smooth. Before we continue, it is always good to group nodes, in order to limit confusion. Select these nodes, Ctrl-J. That puts them in a frame. This frame is for the inner sphere. There is also an option for assigning color. Select these nodes. The selected nodes are responsible for creating the rounded faces, which are going to be the mirrors. Ctrl-J to put the selected nodes in their frame as well. Label the frame as mirrors. Lastly, select these nodes, Ctrl-J once more to put them in a frame. This frame is for the rings. The good thing about frames is that you can select, then press G, to move them around. If you go to the mirrors section, you realize that this scale elements node controls the scale of both the mirrors and the rings. As you can see, they are scaling uniformly. What if you want to get a random scaling effect? In this case, you can use a Musgrave texture to get the random scaling effect you are looking for. If you connect height value to scale, you can see that randomness has already been achieved here. Some are small while others are big, with no particular order or pattern. On this Musgrave texture, change it to 4D. Changing it to 4D gives us this W value that you can use in animation. If you adjust the W value, you can see how the scale of the elements becomes random. Normally, when you want to animate such values, you usually go to frame 1, then insert a keyframe. Then go to a frame like 120, change the value, and insert a keyframe once more. So if you play the animation, you see how they are scaling up and down. In this scenario, we are not going to use any keyframes. Therefore, I am going to clear keyframes in this Musgrave texture. That is because there is a better procedural way of achieving a similar effect and doesn't require keyframes. Add in scene time node, then either connect seconds or frame to W of Musgrave texture. If you play the animation, you can see that the objects are scaling up and down quite fast. In order to slow them down, you will need a math node and connect it here, then change it to multiply. Multiply scene time by a small value like 0.01. If you play animation again, you see that the effect has been slowed down. Generally, what is happening here is that this Musgrave texture is affecting the scale of these objects up here in a random manner. The scene time node outputs the current time in the scene's animation in units of seconds or frames. Add in a map range node and connect it here. Disable clamp on the map range. This map range node is going to remap a value from a range to a target range. To get the desired effect, you adjust the values in the map range node. Increase from minimum value to 0.25. Reduce from maximum value to 0.9. Increase to minimum value to 0.2. Lastly, increase to maximum value to 1.2. If you mute the map range by pressing M, you can see that the rings are generally small. When I enable the map range, you can see that some rings have become larger. The next step is to make these rings spin around the inner sphere. The mirrors and the rings are going to spin together as a whole. Therefore, we need to combine them together by using a join geometry. The rotation effect is going to take place here after the join geometry. Add in a transform geometry node and place it here. Here, we are going to make these elements rotate along all axes at once. In order to do that, we are going to use this scene time node, which is going to affect the rotation in this transform geometry node. If you play animation, you see that the rotation is vigorous, it needs to be slowed down. Add a math node and connect it here. Set it to multiply. Multiply scene time by a small value like 0.01. You can see that these noodle is cutting through these frame. We need to create a reroute node. Shift right click and drag on this noodle to create a new reroute node here. Select and press G to move it to an empty space down here. Create another reroute node here by shift right click and drag. It is now time for adding materials to this object. Split this area, then change this right side to be shader editor. Also change the 3D viewport to be material preview. Go to material properties, then let's create a new material. This one is going to be for the rings. Change its base color to yellowish. Set its metallic value all the way to 1 and roughness to 0.1. You can see that the material is assigned to the inner sphere. In order to assign the material to the rings, we are going to do it in geometry nodes. On the rings frame, the material is going to be set right after this join geometry. Therefore, add in a set material node and connect it here. You can select the material you want from here. The next step is to create a material for this mirrors. Go to the mirrors frame, then add in another set material node and connect it here. Create a new material, then rename it to mirrors. Set metallic all the way to 1 and roughness to 0. You can now set the mirrors material from the geometry node editor. You can see that the mirrors geometry are not smooth. Add in a set shade smooth node and connect it here. Lastly, we are going to make a material for this inner sphere. Create a new material, rename this one to inner sphere. Before we continue, let's assign the material to the inner sphere in geometry nodes. Add in a Musgrave texture, then connect color to the principled BSDF this way. Add in a color ramp and connect it here. Move these color stops closer to each other this way. On this noise texture, change it to 4D. Adjust the scale value to 8. Set detail value to 5. Increase roughness value to 0.8. We are going to adjust the lacunarity in order to change the overall look of the noise texture. Set it to be 50. On this color ramp, let's change this white color to yellow, then reduce the saturation. Change this black color to gray. Add a new color stop to the color ramp and change the color to yellow. Add another color stop to the color ramp, change this one to red. Let's keep on adjusting these color stops in order to get the desired effect. The next step is to add an animation effect to this material. Make sure that you have enabled the Node Wrangler add-on in the preferences. Once Node Wrangler is enabled, select Noise Texture and press Ctrl-T in order to generate the mapping and texture coordinate. On the mapping, we are going to add animation in the rotation section. The animation is going to be on the Z rotation. Since the Z rotation is the only one to be used, we are going to need a combine XYZ node. Connect it to rotation. Add in a value node and connect it to the Z input this way. In order to change the Z rotation of the material, we are going to insert a driver in this value node. That is going to be #, frame, asterisk, then 0.005. This is an expression that means the value will be equal to the current frame number multiplied by 0.005.